you've got probability of E intersection F is the probability of E times by the probability of F, and you're asked to say, basically in part A, what does that mean? We're looking for one word. If that is true, E and F are
Equal.
not equal, independent, yes. So your answer there is E and F are independent. That is the definition of independent, if E and F is E times F. So the key word there, independent, for 1 mark. B, so the probability of E and F was equal to 0. What does that mean in terms of Venn diagrams?
They don't touch.
Well, yeah, there's no overlap, okay? So you cannot be in E and F at the same time. What is the key phrase we use for that one? What were they looking for there? Mutually exclusive. Brilliant, yes.
Can you have it if you were both happening at the same time for the first one?
No, they would be looking specifically for that word independent, I'm afraid. Okay? Right, now we've got some probabilities, so maybe it's time to do a Venn diagram. We have E and we have F. We know, what do we know? E is a third, so altogether in E I've got a third. F altogether is a half. And I know that not in E and in F is a half. It's not in E and it is at the same time in F as a half. That's got to be there. That bit is not in E but in F. So if there's a half there, what's in the middle? Nothing, which corresponds with what they said up here. E is a third. Well, if none of it is in there, all of that third must be in that bit. What do those 3 fractions add up to give you? Do you know? Okay. They add up to be 5/6. So if those numbers add up to be 5/6, what is still left to go in there somewhere? Sorry?
6.
Yeah, 1/6. Okay. So we can draw the Venn diagram. So the relationship between E and F in this part of the question, well, which of these things here is true? It's going back here. Are they independent? Are they mutually exclusive? They're mutually exclusive. So part C, the answer again is they are mutually exclusive. There's no overlap. Can't be both at the same time. D is a probability of E given F. So that's a probability of E and F over the probability of F. E and F's the middle bit, that's 0. Well, regardless of what I divide it by, and I might not even bother finishing it off, 0 divided by anything is 0. So that probability was 0. And E, which is the final bit, was the probability not in E and not in F. Which bit of the diagram is not in E and at the same time not in F? The outside, yep, so that was the 1/6 that someone told us earlier. Okay, so that's question 3. The breakdown is there, 8 marks altogether. I'll let you allocate the method marks as you see fit from what I've done.